So what we're going to do for this problem here is try to balance this pretty intense looking chemical equation. And what we can see that we've got is basically 6 molecules, 2 going in, 4 going out. If we look at any particular element, let's say lead, we see there's that first molecule with 1 lead piece going in. And then we can see on the right-hand side, that's going to be 3 going out. Clearly, this is not balanced. So what we need to do is find some coefficients to throw in front of each of these molecules so that what we actually get is the same number of elements going in and coming out from the entire equation. So I'm just going to use x's for each of the coefficients. And I'll just label all of them. And there's going to be 6 in total. So that does mean that we have 6 variables, each of these x's. And hopefully there's enough actual equations here to solve for all of them. So if we go back and look at the lead, for example, what needs to happen is the same number comes in as goes out, and that allows us to establish an equation. So if I set up this equation for lead, the incoming lead is going to be just the 1 times whatever this x1 from that first molecule. And the only other molecule that shows up is the third one on the right. And so we can see there's 3 within the molecule, but then we're going to have x5 of that molecule. So it's 3 times x5. And then we'll move our way across. We have to go through all of these different elements. The next one's nitrogen. And if we have a look at this one, just the way that what these brackets mean here is there's 3 of them inside the bracket and then 2 of those chunks. So what that means is that we actually have 3 times 2 equals 6 in total. So for that first molecule, what we'll actually have is 6x1. And then the n doesn't show up again until the very last molecule, and that'll be equal to x6. And we just do this for all of them. So chromium is next. So we can see just that second molecule has the 1 chromium. And on the right-hand side, so we need this to be equal to, it's just the first molecule on the right. And there's 2 of them, and they'll be attached to the x3. So next up, we're going to move on to manganese. And again, we have one of these brackets coming up again. So we can see the manganese is inside this bracket with the 2. So there's 2 of them. And I might as well just go ahead and look at the O4 because that's going to come up next. And there's 4 times 2 of them. So there'll be 8 in total. But I'm going to go back to the manganese right now. So on the left, we've got the 2 attached to that second molecule, x2. And then on the right, it's only showing up in the second molecule, which is going to be the x4. And now on to the O, and this one is where it starts to get a little bit more interesting. So what we can see here is I got the 8 from that second molecule, which will be attached to the x2. And then all of the molecules on the right actually have this oxygen piece. So this is where it gets a little bit more complicated. So I have a 3 on the first one, and 2 on the second one, and 4 on that third one, which will be x5, and then just that 1 on the x6 piece. And I think that is all of our elements. So we are going to get 5 equations in 6 variables. So you should be aware, like immediately, these are going to be homogeneous equations. And we are going to have a free variable here. It's guaranteed because we do have less equations than variables. And so what we've got to do now is put this into a matrix and solve. So I'm just going to get this in the right format. So this will be x1 minus 3x5 equals 0. And we'll just go through and put the rest of them all on the left side of the equation. All right, and so we've got them all moved over. And so what we want to do now is put them in the matrix. So I'm going to line up my x1s will be 1, 0, 2, 0 for 3, 0 for 4, -3 for x5, and 0 for 6, and then a 0 on the right. And then, yeah, just go ahead and put the equations into the matrix. We'll get our matrix set up. And so what we're going to do is, just put this as close as we need to reduced echelon form. So I think my first step I'm going to do is get rid of that 6 there. Row 2 is going to be row 2 minus 6 of row 1. And then while I'm doing that, I can see those bottom 3 rows don't really interact much, at least with that first pivot with the first 2. So then I'm also going to do row 5 is row 5 minus 2 of row 3. And row 6, sorry, that was row 4 there. over counting rows. So row 4 is row 4 minus 2 of row 3, and row 5 is going to be row 5 minus 8 of row 3 to get some zeros down there. And so the 4 and the 13 don't deal with each other too nicely, but I can at least turn that 13 into a 1 by subtracting 3 4s from it. So row 5 is going to be row 5 minus 3 times row 4. And I'm going to need some more space. So I'm going to squeeze all this down. And so now I can get rid of that 4 and might as well get rid of the -2 above it with what's going to look like a pivot right there. So I'm going to do row 3 plus 2 of row 5, and row 4 minus 4 of row 5. And so from here, I could do some rearranging, but we can hopefully see the without necessarily rearranging it, put it properly in echelon form. But I see my pivots. I've got first, second, third column. I don't actually have a leading entry in that fourth column, but I can see this 18 is also a leading entry. And so we should be able to actually go ahead and solve for that. And so, oh, sorry, no, I do. I have that -5 in the fourth column. So yeah, we have all of those first 5 columns. It does mean that my last column is going to be my free variable. So I'm going to call that t. And so, yeah, I'm just going to go ahead and generate some solutions for this. So that second equation, if I have a look at it, it does basically say that x5 is going to be, well, 18x5 is equal to x6. So if I rearrange that and throw the t in, I get x5 is t over 18. And then looking at now that moving back to the next pivot is going to be that -5. So that's going to be row 4. So this says that basically -5 x4 plus 16 of x5, which is that t over 18, and then plus 4 t is going to be equal to 0. And that's going to allow us to actually solve for the x4. Which if we rearrange, we are going to get 44t over 45 with a little bit of simplification of the fractions. And so we just kind of keep making our way through these and solving them very much the same way. Row 5 is going to now tell us what x3 is. So I'm going to get x3 plus x4, which we just said was 44t over 45, minus 4x5, which is t over 18, and minus t, which is x6, is 0, and that's going to allow us to solve for x3. And so we end up rearranging this and getting x3 is 11t over 45. And just two more rows to go here. So row 3 tells us that x2 plus 2 of my x4, which we solved for here, was 44t over 45, and minus 8x5, which is t over 18, and then minus x6, so minus t is 0, and so that tells us that x2 is going to be, I just realized a bit of a problem in the calculation. I was missing a 2 here on that equation. I was getting a negative for the x2, which is a little bit of a problem. And so if we actually do put that t2 in there and solve it the way it should be solved, we do end up getting x2 equals 22t over 45. And then finally, the last one's not so bad. R1 is going to actually give us an x1 minus 3, and that's times x5, which is t over 18, equals 0. And so that one's a little easier to solve. It'll be x1 is t over 6. And so from here, what we want to do is basically choose the t that gives us the least possible integer solution here. All of these fractions are written in lowest terms. So basically, we want to choose the smallest t that wipes out all of the denominators. So there's obviously going to be some 45 in there, but because of the 18 and the 6, it also needs to be even. So if we actually choose t equals 90, that's the least common multiple of all those denominators, and that should give us our solution. And yeah, if we make our way through, we'll get x1 is 15, x2 is 44, x3 is 22, x4 is going to be 88, x5 is 5, and then of course x6 is t, which is 90, and this should be the set that actually balances this equation.